Hello and good afternoon friends, welcome to CEC live lectures. Dear friends, today in this session we are going to talk in our series on microeconomics. Today we are going to discuss on elasticity of demand, concept and measurement, and for this discussion we have once again with us in our studios Dr. Bharat Singh. Dr. Bharat Singh is Associate Professor in Department of Economics, Satyavati Evening College, University of Delhi. Dear friends, if you want to ask questions from Dr. Bharat Singh, then you can call straight right in the studios, and you can contact us through our toll-free number. Our number is 1-800-110-430. I repeat, our number is 1-800-110-430. So let's welcome our guest, Dr. Bharat Singh, and let's try to have a deep insight into today's topic. Hello sir, welcome to the lecture.
Thank you, Geetika ji, and welcome to all the students and the viewers of this program. And perhaps you may be aware that this topic, elasticity of demand, is a very important topic of microeconomics, because till now in different lectures of this series we have come to know that the law of demand states that there exists an inverse relationship between price and quantity demanded of a normal good. So law of demand merely states a directional relationship, and it states that the direction of movement of both the price and quantity demanded of a normal commodity is in the opposite direction, happens in the opposite direction. And by studying and knowing different dimensions of the law of demand, we just know as to what kind of relationship exists between price and quantity demanded of a commodity, whether for a normal commodity or for an inferior commodity or a given commodity. This law of demand does not change as to what extent the demand would change in response to a given change in the price of a commodity, or for that matter any of its determinants, say price of the commodity, income of the consumer and prices of the related goods. This question as to the extent of change or dimension of change or magnitude of change in the quantity demanded of a commodity in response to a unit change in any of its determining factor, any of the determining factor of the quantity demanded of a commodity is known by knowing the concept of elasticity of demand. So of course it's very pertinent to know for all of us that as to what is elasticity of demand and what are its different methods to measure the elasticity of demand, and its importance in day-to-day life of a consumer or the producer or the policy making by the government, so on and so forth. So elasticity of demand simply refers to the responsiveness of quantity demanded of a commodity to a change in any of its determinants, and as I stated earlier just now that the determinants of demand, which was reflected through demand function, is the price of its own, the income of the consumer and the prices of the related goods. Thus elasticity of demand shows both direction and degree of change in demand in response to change in any of its determinants, that is price, income and prices of the related goods. Accordingly, there may be three types of elasticity of demand. Since here we are taking into consideration only three factors of change in demand, so only three types of elasticity of demand may be perceived at this moment of time, because there may be other factors which determine the quantity demanded of a commodity, say for example the taste and fashion preferences of a consumer and several other factors. But since those factors are not quantitatively measurable so easily, therefore as a limitation for the time being we are considering only three important factors of demand for a commodity, and therefore, only three types of elasticity of demand will be discussed at this moment of time. First is the price elasticity of demand. We all know that price is by far the most important determinant of demand for any commodity. So, price elasticity of demand refers to the responsiveness or degree of change in demand for a commodity as a result of change in price of the good alone. Here we are presuming that other factors, say income of the consumer and prices of other commodities, remain same, and to what extent the quantity demanded of a commodity is sensitive or responsive to a change in the price of the commodity itself. The second type of elasticity of demand would be income elasticity of demand. The income elasticity of demand refers to the responsiveness or degree of change in demand for a good as a result of change in income of the consumer again alone. So, here we are presuming that only income of the consumer is changing, and to what extent demand is responsive or sensitive to a change in the level of income of the consumer, assuming that the price of the commodity itself and prices of other goods remain same. Third, again, if we assume that price of the commodity itself and income of the consumer is the same, it does not change, and only the price of other goods, say for example the complementary goods or the substitute goods changes, to what extent the price of a particular commodity, say X, is responsive to the change in price of any other commodity, say for example Y. So, this, if we try to measure the degree of responsiveness in this sense, it is considered as, or it is known as, the cross elasticity of demand. So, we have three types of the elasticity depending on three important factors or three important determinants of demand for a commodity. One is the price elasticity, the other is the income elasticity, and the next one is your cross elasticity of demand. So, price elasticity of demand obviously measures the degree of responsiveness or sensitiveness in the change in demand as a result of change in price of the commodity alone, other factors remaining the same. In other words, elasticity of demand, price elasticity of demand is expressed as a ratio of proportionate change in quantity demanded, that is denoted by Q, as a result of proportionate change in its price alone, that is represented by P. So, this can be expressed as is evident in this slide, that price ED equal to proportionate change in Q divided by proportionate change in P, or elasticity of demand is equal to this proportionate change may again be expressed as the ratio of change in Q and original Q. This is the proportionate change, and in simple arithmetic term it can be expressed as change in quantity demanded divided by the original quantity demanded. This quantity, this should be whole divided by again change in price upon original price. So, if we summarize this exposition in a more precise manner, it would be expressed as follows: elasticity of demand is equal to delta Q upon Q, this whole divided by delta P upon P, where delta obviously denotes the change in P and Q respectively, or it can again be expressed as delta Q upon Q multiplied by P by delta Q. It is just the rearrangement of the above equations of elasticity of demand. And finally, we can write elasticity of demand is equal to delta Q by delta P multiplied by P upon Q. Since change in price and demand are inversely related, therefore, the minus sign may be prefixed before the formula for elasticity of demand. We all know that if the two variables are negatively or inversely related, so their proportion or their multiplication would also be turn out to be negative. So, it is presumed that owing to an inverse relationship between price and quantity demanded of a commodity, the elasticity of demand figure would also be expressed as negative, or minus sign would be prefixed before the value of the elasticity. Therefore, it is the standard practice to ignore minus sign before the formula, and only the absolute value of the elasticity is considered. The price elasticity of demand may also be expressed as percentage change in quantity demanded upon percentage change in price. In true sense, this the formula of elasticity of demand is stated as above: delta Q upon delta P multiplied by P upon Q is one and the same thing as elasticity of demand is equal to percentage change in Q divided by percentage change in P, mainly because of the fact, if we divide this delta Q by delta P by 100 and P by Q also by 100, then it would turn out to be a percentage formula. We will discuss this method in our later slides. Depending on the value of the price elasticity of demand, there may be 5 types of elasticity of demand. One is the perfectly elastic demand, in which the value of the absolute value of the elasticity of demand turns out to be infinite. The second is perfectly inelastic demand, where the value of elasticity of demand is equal to 0. And third is unitary elastic demand, in which ED is equal to 1. And fourth is elastic or greater than unitary elastic demand, that is ED greater than 1. And 5, inelastic or less than unitary elastic demand, in which ED is less than 1. Now, perfectly elastic demand or ED is equal to infinite. Here, a very small decline, this type of elasticity of demand refers to the situation in which a very small decline in price of the good causes an infinite increase in demand for the good, and a very small increase in price causes the demand to fall to 0. And it may be noted that both these cases, that a very small decline in price results into a very huge or almost infinite increase in quantity demanded, and vice versa, is probably an extreme case of elasticity of demand, and it is rarely observed in our real life. This is the diagram showing the perfectly elastic demand, in which OX axis shows the quantity demanded of a commodity and OY axis shows the price of the commodity. And we can see with the help of this diagram that demand curve is parallel to x axis, and if the seller or the producer attempts to increase price even slightly, the demand is likely to become 0, and if the price falls even by a very minuscule amount, the demand has no limit to increase, as is evident by the PD demand curve. So, this is again, I said just now that this is a very rare case, or in real life observation we hardly find an example where elasticity of demand is perfectly elastic. Perfectly inelastic demand, ED is equal to 0. This is another exceptional case of price elasticity of demand. If the price elasticity of demand for a good is perfectly inelastic, the demand does not change at all in response to any change in its price, because it is perfectly inelastic, and demand is not at all sensitive. Its sensitiveness to change in price is totally nil, it is 0. So, this is also known as a zero elasticity of demand case. Such cases may be observed if the goods are extremely necessary or highly luxurious goods to be used by highly rich people. This is the diagram of perfectly inelastic demand, in which ED equal to 0. Here again OX axis represents the quantity demanded of a commodity, and OY axis represents the price of the commodity. DD is the demand curve, and it is lying vertical on the x axis, in which it is evident that whatever be the level of price, whether price increases or decreases, the quantity demanded of this commodity remains totally unchanged. It remains totally unresponsive to any change in price. So, the quantity demanded remains fixed at OD, whatever may be the level of price. Such type of elasticity of demand may be observed, but less than normal. Unitary elastic demand, wherein ED is equal to 1. If the demand for a good shows elasticity of demand ED equal to 1, then the percentage change in quantity demanded is equal to percentage change in price. Conversely, if percentage change in Q is equal to percentage change in P, it represents a case of unitary elasticity of demand. In such cases, the total expenditure P into Q on the good remains the same, both in situation of increase or decrease in price of the good. The shape of demand curve is rectangular hyperbola. So, unitary elasticity of demand is a situation in which the percentage change in price and quantity is the same, both in case of increase and decrease. If the price of a commodity increases by certain percentage, the quantity demanded also falls by the same percentage, and if the price of the commodity falls by some percentage, the quantity demanded of the commodity increases by the same percentage, resulting into fact that the total expenditure incurred on that commodity remains the same. This is a very important method, or rather indication of the existence of elasticity of demand. So that by observing the behavior of expenditure incurred on a commodity, we can predict about the nature of elasticity of demand for a commodity. Owing to such a kind of relationship, the demand curve showing the unitary elasticity of a commodity is a rectangular hyperbola, which is shown here, and in this diagram it is evident that OX axis represents the quantity demanded of a commodity, OY again shows the price of the commodity, and we can see that if price of the commodity is OP2, the quantity demanded is OQ2, and if price increases from OP2 to OP1, the quantity demanded falls from OQ2 to OQ1. So, here we can see that the area OPMQ1 and the area OP2NQ2 are the same. So, both these areas show the same dimension, which means that either in case of increase or decrease in prices, the total expenditure remains the same. Therefore, because total expenditure is price of the commodity multiplied by quantity consumed. So, since the total expenditure in both the cases remains the same, therefore, it is an indicative of the fact that it shows the unit elasticity of demand. The fourth case is elastic or greater than unitary elastic demand, ED is greater than 1. It represents a situation in which percentage change in Q is greater than percentage change in P, which means that the demand for the good is relatively more responsive, more sensitive to any change in its price. And what does it mean? It means that the rate of change in quantity demanded of a commodity is more than the rate of change in its price. If the price falls by certain percentage, then quantity demanded increases by more than that percentage and vice versa. And further we will discuss the other types of the elasticity. Thank you very much. Okay, welcome all the viewers once again. So, I was just going through the fourth type of the elasticity of demand, that is the situation where ED is greater than 1, and I was trying to explain that in such case where ED is greater than 1, the proportionate change in quantity demanded is greater than the proportionate change in price. If the price falls by certain percentage, say by 1%, the change in the increase in quantity demanded would obviously be greater than 1%. And if the price increases by 1%, the fall in quantity demanded would be more than 1% again. So, what I mean to say that if ED is greater than 1, the demand is sensitive more than the price. So, whatever is the change in price, demand changes by more than that. So, what is its effect on the total expenditure? In this case, the total expenditure on the good increases in case of fall in price and vice versa, because if the price falls, it has a very obvious impact on total expenditure to fall, because if price falls, P into Q, the P factor, since it is declining, it results into decline in the expenditure, total expenditure on the commodity to be incurred. But since the quantity demand, the volume of quantity demanded is more than the fall in price, it more than compensates the total expenditure, and as a result, total expenditure, the net result is that the total expenditure has a tendency to increase in case of fall in price, and by the same argument, total expenditure has a tendency to fall in case of you can say increase in price. The demand curve is relatively flatter in shape, as is evident by this diagram, in which DD is the demand curve, and when price is OP2, the quantity demanded was OQ2, but if price increases from OP2 to OP1, the quantity demanded fell very intensely from OQ2 to OQ1. We can observe here the comparative change in the price of the commodity and its resultant change in quantity demanded. If we look at this phenomena from a different angle, and we presume that originally price was OP1 and quantity demanded was OQ1, and if price fell from P1 to P2, the quantity demanded increased more than proportionately and it became Q1 to Q2, which is reflective of the fact that here the demand for this commodity is more than elastic, and this is more than obvious by the given diagram. The last one in this type of elasticity, price elasticity of demand, is your ED less than one correction here. In the above diagram, when price is OP1, total expenditure is the area OP1 MQ1. If price is OP1, total expenditure is OP1 MQ1. So, see this area shows the total expenditure. If price falls from OP1 to OP2, in this case, if price is P2, in this case the total expenditure would be OP2 NQ2, OP2 NQ2. And if we carefully look at both these area, that is OP1 MQ1 on the one hand and OP2 NQ2 on the other hand, then we will find that area OP2 NQ2 is greater than area OP1 MQ1. Thus, total expenditure increases in case of fall in price and vice versa when price elasticity of demand is greater than 1. Conversely, we can say that if ED is greater than 1, then total expenditure would increase in case of fall in price and it would fall in case of increase in total expenditure would increase in case of fall in price and it would fall in case of increase in price. The last one is elasticity being less than 1 or relatively inelastic demand. This type of elasticity of demand represents a situation in which percentage change in Q is less than percentage change in P. The demand for the good is relatively less responsive to any change in its price. If the price of such good fall, the demand increases less than proportionately and vice versa. As a result, total expenditure on the good falls in case of fall in price and it increases in case of increase in price. And the demand curve is relatively steeper in shape. This is the demand curve for a commodity whose elasticity of demand is relatively inelastic or ED is less than 1. Here again x axis represents the quantity demanded of a commodity and OY the price of the commodity. If price is OP1, the quantity demanded is OQ1, and if price falls from P1 to P2, the quantity demanded increases from OQ1 to OQ2, and here elasticity of demand is less than unity. In the above diagram, when price is OP1, total expenditure is the area OP1 MQ1, OP1 MQ1 if the price is P1. Now, if the price is P2, price falls and it becomes P2, then total expenditure on this commodity would be represented by the area OP2 NQ2, OP2 NQ2. Here again the area OP2 NQ2 is less than the area OP1 MQ1, OP1 MQ1. Thus, the total expenditure decreases in case of fall in price and total expenditure increases in case of rise in price when price elasticity of demand is less than 1. Now, the next issue in this chapter, in this topic would be the measurement of price elasticity of demand, and whatever be the value of the price elasticity of demand, we will find 5 situations. One is the case where elasticity of demand is equal to infinity. The second situation may be the case when ED equal to 0. The third situation may be the situation in which the percentage change in price and percentage change in quantity demanded are same. So, in that case it is known as the unitary elasticity of demand. The fourth case may be ED greater than 1, in which the percentage change in quantity demanded is more than percentage change in price. And the fifth one is case of inelastic demand, in which ED is less than 1, where percentage change in quantity demanded is less than percentage change in price of the commodity. Now, measurement of price elasticity of demand. Traditionally, we have 3 methods of the measurement of elasticity of demand. One is the proportionate method or percentage method, the other is the point method and the graphic method, and the third one is the total expenditure method. The arc elasticity is a variant of the point elasticity or graphic method of measuring elasticity, and revenue method is nothing but a way of showing the relationship between the average revenue, marginal revenue and elasticity of demand. We will discuss one by one what these methods state about the measurement of the price elasticity of demand. So far as the proportionate or percentage method is concerned, it originates from the fact that elasticity of demand states a proportionate change in quantity demanded as a result of some proportionate change in price of the commodity. And if we elaborate this relationship, how to elaborate the proportionate change in quantity demanded and proportionate change in price. The proportionate change in quantity demanded is nothing but the ratio of net change in quantity demanded and the original demand. And similarly, the proportionate change in price would refer to as net change in price of the commodity, ratio of net change in price of the commodity and the original price. This would be expressed symbolically as follows, which is evident in this slide. Thus, ED is equal to delta Q upon delta P multiplied by this whole quantity, delta Q by delta P within bracket multiplied by P upon Q, the ratio of P upon Q within bracket, or ED equal to delta Q by delta P the price elasticity of demand may also be expressed as a percentage change in demand, quantity demanded divided by percentage change in price, where delta Q is given by delta Q upon original Q multiplied by 100 and percentage change in P is given by delta P upon P multiplied by 100. So, we have converted the proportionate change into percentage, both these entities, the quantity demanded and the price. So, therefore, ED in a simple term may also be expressed as percentage change in Q divided by percentage change in P. According to this method, ED can be measured on any point of a demand curve. We are talking about the point method or the graphic method, and we have already seen that to measure the elasticity of demand by percentage method is quite simple. We have just to compute the percentage change in quantity demanded of a commodity and percentage change in price, and we have to divide the percentage change in quantity by percentage change in price, and whatever value comes, we can categorize that absolute value on any of those 5 parameters and accordingly say that this is whether this is unit elasticity case or it is infinite elasticity, zero elasticity, greater than unity or less than unity. According to point method or graphic method, the elasticity of demand can be measured at any point on the given demand curve if the change in the price and quantity demanded is very small. On the given demand curve, ED is different at different points. The simple formula to measure ED on any point of a given demand curve is the lower segment from that point where elasticity is required to be measured, lower segment of that demand curve divided by the upper segment of that demand curve. This diagram, I think, vividly represents, it explains the different values of elasticity along a given demand curve, and we see that in this diagram Mn is the given demand curve, and if we want to measure elasticity at point P, say for example at point P, which is the midpoint of the given demand curve Mn. So, here the lower segment would be Pn and upper segment would be Pm. So, what would be the value of elasticity in this diagram at point P? It would be Pn divided by Pm, and by this diagram it is obvious that the length of Pn segment of the demand curve is equal to the length of the Pm segment of the demand curve. So, therefore, its absolute value would be equal to 1. Therefore, it represents the unit elasticity case of elasticity of demand. Similarly, if we want to measure elasticity at point A, then lower segment is An, upper segment is Am. So, here elasticity of demand is greater than 1 because the numerator An is greater than denominator Am, and by the same logic elasticity of demand at point M would be infinite because lower segment consists of Mn. Mn is the entire demand curve and upper segment is equal to 0. So, any quantity divided by 0 is obviously infinite. At point B of this given demand curve, the lower segment is Bn while the upper segment is Bm, and so the elasticity here would be less than unity because the numerator, that is lower segment, is a smaller quantity and upper segment, that is the denominator, is a greater quantity. So, this ED value has to be less than something which is less than 1. At point N, ED would be equal to 0 because lower segment is 0 and upper segment is the entire segment of the given demand curve. One thing is clear here, that by the point method or the graphic method, we do not get the actual absolute value of the elasticity of demand, rather we just get an indication at that at any particular given point of the demand curve, whether ED is greater than 1, equal to 1, less than 1, 0 or infinite. We do not get the absolute actual value of the elasticity of demand measured through this method, that is point method or the geometric method. This graphic method is also known as geometric method of measuring price elasticity of demand. Now, in the above diagram, in this diagram, we see that we have used a straight line demand curve to measure different elasticity at different points of the demand curve. What would happen if the demand curve is not a straight line demand curve? It is, say for example, it is a non-linear case of demand curve, or in this case, how to measure elasticity of demand, because here it is difficult to find the lower segment and upper segment of demand curve on any particular point, because the demand curve is not touching either x axis or y axis. So, the way out, what is way out here? The way out is to draw a tangent along a given point on the demand curve, which is non-linear. And say for example, dd is the demand curve, it is a non-linear demand curve, and we want to measure elasticity at point P. What should be done? Simply we have drawn a tangent Mn along the point P of the dd demand curve. Now, the same formula, that is lower segment by upper segment, would be used, would be applied here to measure elasticity at point P. So, there is not much difference whether the demand curve is a linear demand curve or it is a non-linear demand curve. The same formula, simple formula, lower segment by upper segment would be used. In this case, elasticity of demand at point P would be Pn upon Pm, as is evident by this diagram. The third method is total expenditure method. The total expenditure method was devised by Professor Marshall. He suggested that by observing the behavior of total expenditure, the degree and direction of ED can be established, and the converse is also true. In other words, if we know the value of elasticity of demand, we can predict about the behavior of likely change in the behavior of the total expenditure incurred on a commodity. Thus, total expenditure does not provide any. Yes.
So we have a caller from
Varanasi.
Yes. Hello.
Hello, ma'am.
Yes. Please tell your name.
Ma'am, I want to ask a question.
Yes. Please ask a question.
Yes, ma'am. What is the effect of elasticity of demand on consumer behavior?
On consumer behavior, you want to know the elasticity of demand.
The effect of elasticity of demand on consumer behavior.
He wants to know the elasticity of demand on the consumer behavior. What effect does it produces on the
The consumer can decide about the purchase of a commodity on a particular commodity, taking into consideration as to what impact it would have if the price of the commodity changes. I have explained that there are three determinants of the quantity demanded of a commodity: the price, income, and the prices of the other goods. If the consumer, if the demand for a commodity is highly elastic, then the consumer can think whether he should increase or decrease his demand, because if the demand for the commodity increases, the price is likely to increase, and the consumer may be at a loss.
Hope, dear friend, you might have got your answer, and friend, please keep calling us so that your queries are resolved and you get the in-depth knowledge on the topic. Yes, sir, let's continue further.
So, thus total expenditure does not provide any precise measure of the ED, rather it provides a relationship between ED and total expenditure, elasticity of demand and total expenditure. Three types of relationship between elasticity of demand and total expenditure may exist. One is that if ED is greater than 1, total expenditure increases with a fall in P, and T decreases with, T means total expenditure, decreases with a rise in P, P means price. The converse is also true. In other words, change in P and total expenditure move in the opposite direction. If elasticity of demand is less than 1, total expenditure increases with a rise in P and T decreases with a fall in P. The converse is also true. In other words, change in P and T move in the same direction. If ED is equal to 1, total expenditure does not change whether price of the commodity rises or falls. This is the diagram showing the relationship between change in price of the commodity and total expenditure. Another method is your arc method, in which the elasticity is measured over a range of the demand curve. Here we have tried to measure elasticity between points A and C, and if price is OP1, quantity demanded is OQ1, and if price increases to OP, the quantity demanded falls from OQ1 to OQ. What would the elasticity in this case? Here the average of both the price and quantity is taken. The average of the original price and original quantity. Accordingly, the formula which is used to measure arc elasticity is P1 plus P divided by Q1 plus Q multiplied by delta Q. Delta Q is change in quantity demanded upon change in price. So, here the average of price P1 plus P is taken and average of quantity Q1 plus Q is taken. The next method is your revenue method, and I told you in earlier part of this lecture that in fact revenue method is not a method to measure elasticity, rather it is a way to express the relationship between elasticity of demand and average revenue and marginal revenue, and the relationship exists like this, that ED equal to AR upon, it means divided by within bracket AR minus MR. And in the following diagram, again ED at point P is equal to PB upon PA, again lower segment by upper segment. This is the AB demand curve. At point P, the elasticity would be PB upon PA. Thank you very much, and we will meet in the next session of this lecture.
Definitely, we will be meeting again and we will be discussing further. And dear friends, we want you to write to us at info.cec@nic.in. If you have any feedback or suggestion for today's lecture, the lecture is going to be uploaded on YouTube soon. So keep watching us, keep writing us. Thank you so very much.
Thank you very much. Thank you.